Today we're continuing to look at our concept graphs of functions, and the essential question we're looking at today is how do we determine the intervals on which a function is increasing or decreasing. And actually there's a third option not listed in this question, and that is if it's not increasing or decreasing, what about when the function is constant? That's a third option that we'll consider in today's lesson. As we start talking about increasing, decreasing, and constant nature, the one thing that I want to emphasize is that when we write our answer, the answer is always an interval of x values. So that's going to be really important because the increasing, decreasing, constant part is going to describe the y values, but our answer is going to be the interval x values. So keep that in mind as we go, and as we describe the nature, increasing, decreasing nature, we're going to make sure our answers are x values. If there's going to be one mistake that's commonly made, it's going to be confusing x and y coordinates as part of our answer. Okay, an increasing portion of a graph is when the y values increase as the x values increase. And what kind of a shape does that take for our graph? The y values increase as the x values increase. That's up and to the right. That's what that looks like. So in the example graph that we have, what portions of this graph are going up and to the right? You can see this portion that I'm tracing here up to some certain point, like maybe right there. This portion of the graph is going up and to the right. Somewhere right around here, it stops going up and to the right. And if we sort of continue, but we pick up our pencil, somewhere down here, the graph starts going up and to the right again. So there's this graph that I have, this example is actually has two portions of it that are going up and to the right. This first portion and this last portion. Okay. What's happening in between there, as you might suspect, is the graph is decreasing, and that means the y values decrease as the x values increase. Notice the x values are always increasing because we're always going to the right. This looks like down and right. Decreasing is like negative slope, whereas increasing is like positive slope. Up and to the right is increasing, positive slope. Down and to the right is decreasing or negative slope. So this portion of the graph that we have here, right here, that's obviously going down to the right. We're always going right. We're always going from left to right. So then it becomes a matter, are we going up, which is increasing, or are we going down, which is decreasing? And so you can see this graph changes from increasing to decreasing to increasing again. And the key to describing the portion or the intervals is to figure out where does it switch. What is this point where the graph switches from increasing to decreasing or decreasing to increasing? If I drew this, if I colored this in carefully enough, this x value here is -2, and this x value here is +4. So when we go to describe our answer, we're going to say that this graph increases, assuming off the edge of the screen the graph continues this way, and it continues this way off the edges of our screen. Remember, our answer is the x value. So we know the y values are increasing. We want to know what are the x values involved. So this function increases, we would say from negative infinity, an x of negative infinity, all the way to negative 2. We're actually going to include negative 2 as part of the increasing. So that's this first increasing part. And then it also increases, so we're going to take the union of two sets. It's going to increase from x equals 4 all the way to infinity. And that's the second increasing part. So we use an interval to describe the increasing part. Likewise, what's the decreasing then? Decreasing, we can abbreviate DEC. Decreasing is happening in between the negative 2 and the 4. Again, x values. It might be a little strange, but we're going to include the negative 2 and the 4 in the decreasing interval with square brackets to show this portion of the graph here where it's decreasing. Now, okay, so that's increasing and decreasing. What about constant? Well, what do you suppose constant is? Constant is when the y values don't change as the x values increase. So what's a line look like where that y values don't change as the x values increase? The x values are increasing because we're always going from left to right, and that looks like a horizontal line, or a horizontal line segment. Maybe just one interval is constant, so it's there's a horizontal line segment. In the graph that we have here, doesn't have any constant portion. So that's a quick explanation of increasing, decreasing, constant. Let's look at a few other examples to see if we can't describe their intervals, again, focusing on the x values. Okay, here's a graph that's given to us. We don't know the function, but that's okay because we're going to look at it, the graph, to find out where the function's increasing, decreasing, constant. So immediately, if you just picture up and to the left, up and to the right, that's this portion is increasing and this portion is increasing. So we're going to write those as intervals. Let's assume that this graph continues off the edge that way. So our x coordinate for that first increasing portion is going to start at negative infinity, and it's going to end right here at what looks like 1, 2, 3, negative 4. So negative 4. Again, remember we're including that endpoint on the increasing. And this second portion of the increasing portion looks like at x equals 2, and it ends at 3, 4, looks like x equals 5. So we're going to do from 2 to 5 is the other increasing part. All right, so that's increasing. What about decreasing? There's one decreasing, barely decreasing, but you can see it goes down to the right here. And we've already got the x coordinates, so our decreasing is going to go from x equals negative 4 to x equals 2. Notice we're not even really looking at the y coordinates at all, we're just looking at the x coordinates and picking where the graph goes up and to the right, down to the right, and then this one actually has a portion that's totally horizontal, just flat going to the right. And if we consider that continuing off the edge of the screen, we can say that the constant portion of this graph starts at 5 and goes to infinity. And now we've got our increasing, decreasing constant. Let's try another one. Okay, here's a new graph. It looks like the graph is starting out going down to the right, so we're going to skip that for a second. Then it looks like it starts to increase, and we're going to identify our increasing first. And so that looks like it starts at 0 and goes to an x coordinate of 1, 2, 3, 4. It looks like about x equals 4. So our increasing is from 0 to 4. What about the other portions of the graph? Well, the first portion, let's consider that that keeps going. Goes down to the right, so that's definitely decreasing. So we'd say from negative infinity to 0, it's decreasing. And then this portion where The increasing leaves off is also decreasing slightly, keeps going, so we'll say from x equals 4 to positive infinity, decreasing. Okay, last one. This graph again starts decreasing, but we're going to hit an increasing portion right here. Let's say that starts at 1, 2, 3, x equals 4, and ends at about x equals 6. And then another increasing portion over here, and that looks like it starts right about at x equals 10. So our increasing intervals are from 4 to 6, and from 10 to infinity. What are the other portions doing? This actually looks like maybe two different portions, but it's decreasing still. Sorry about that. This looks like two separate decreasing portions, but it's decreasing nonetheless. And then this here is decreasing as well. So we have our function, let's say that. So it's decreasing from negative infinity all the way to x equals 4. And then it decreases again from 6 to 10. And we've got our intervals.